Hi, yes. Let's first start this class by just doing a very brief review of correlation. Okay, and correlation is one of the fundamental concepts in statistics. It's basically trying to measure linear relations between two random variables. Okay, so right now we are in the point that we have learned some statistics and we're ready to actually apply the statistic to scientific research. And in scientific research, we really care about the relationship between different variables. So correlation is one basic tool for measuring the linear relationship of two random variables. So Pearson correlation coefficients, Spearman's rule, and matrix scatter plots and correlation matrix. These are the topics I want to go over in this brief talk. Correlation is a fundamental concept in statistics. Correlation and simple linear regression measures the linear relationship between two random variables. In other words, correlation is the start of researchers' effort to understand how random variables are related. A scatter plot is a graph in which the values of two random variables are used as the x and the y coordinates. So basically you have x-axis and the y-axis, and you just plot the data points on that graph. A scatter plot is a straightforward data visualization tool for showing potentially the relationship between two random variables. And it's very informative. We can immediately see some relationships, like on the right-hand side, we see 4 scatter plots. The upper left one shows positive linear association. The upper right one shows negative linear association. And the lower left shows nonlinear association. And the lower right one shows no association. So basically, it's a random pattern in there. It is a good practice to statistical data analysis to generate scatter plots for bivariate analysis. Okay. And one of the earliest correlation coefficient was invented by Carl Pearson, who is a pioneer in modern statistics. So he developed this concept and developed a math formula for computing the Pearson's correlation coefficient R. It is a numeric value measuring the strength of linear relationship between two random variables. And here are some of the properties of Pearson's correlation coefficient R. So basically R is between -1 and +1. If R is -1, it means a perfect negative correlation. R equal to 1 means perfect positive correlation, and R equal to 0 meaning low correlation. And if you want to have a sense of the magnitude of the correlation, here's a rule of thumb. The absolute value of R is greater than 0.8. It indicates a strong correlation. Absolute value of R less than 0.2 indicate a mild correlation. Anywhere between 0.2 and 0.8 is considered as a moderate correlation. Okay, and another thing you need to remember is R is very sensitive to outliers and the non-normal data. So in a data set, if you have one outlier, it can really mess up the R value. So when you calculate R, you do want to check outliers, and the distribution also matters too. R is only measures linear relationship. And because of the limitations of Pearson's correlation R, people also developed the Spearman's rank correlation. It is a measure of monotone relationship between two random variables. And it's basically using the ranks of the data points. So it is also between -1 and +1. And +1 or -1 means a perfect monotone relationship. So the assumptions for Spearman's rule are data are independent, the ordinal, interval, or ratio data, and there is a monotone relationship. So these assumptions are really less restrictive compared to the Pearson correlation R assumptions. For example, Spearman's rule does not require normally distributed data and is less sensitive to outliers. Okay, since we are getting into multivariate statistical data analysis in this course, I think one straightforward generalization of the scatter plot and the Pearson correlation R is our so-called scatter plot matrix. For a multivariate data set, a scatter plot matrix is a convenient tool to visualize a pairwise relationship of multiple variables in one graph. Okay, I have posted the link from NIST for more examples. And furthermore, you can add smoothed curves to the scatter plots to actually give you some sense about the pairwise functional relationship between the two variables. So on the right-hand side, you can see an example of a scatter matrix. So directly you get visualize the relationship between here's 1, 2, 3, 4 variables pairwisely, in one plot. And to generate the scatter plot, basically use the SPSS the graphs and scatter, and then select the matrix scatter, and to define and you put those variable names into the matrix variable box and click OK. And also lynda.com has a pretty nice video on scatter plot matrix. You can visualize, you can view. And similarly, for numerical values, we can generate a correlation matrix for a multivariate data set can be used to display correlation coefficients of multiple variables. And the p-value for testing the null hypothesis of each pairwise correlation being 0 is also included in the correlation matrix. So this gives us really a very quick tool just to screening the potential bivariate relationship of multiple variables in a multivariate data set, like in one table. So here on the right-hand side, you can see an example of the output of a correlation matrix. And also in SPSS, you can specify the significance level. So here for this correlation matrix, the significance level is set at a 0.01 level. All right, and that's all for this presentation. Thank you.